Hi everyone and welcome back to Life with Technologies YouTube channel. I hope you're doing well and thank you so much for watching this episode. So this is another episode of our IPRAN training series, and in this session we will be doing a summary of the IS-IS troubleshooting session that we had before. Remember when we did session 8, that was session 8 or 9, we had a loop problem when we were doing the implementation for HOVPN solution. So we had a very successful troubleshooting session, and I want to thank you again for those one who were able to join the session and help in troubleshooting. We were able to find some solutions, and that's why in this session we are just trying to summarize those solutions so that it's easy for you to understand the solutions and the issue that we faced when we did that implementation. So we have the topology. You have BTS connecting to the UPE, and then UPE connects to SPE connects to NPE, and we have the controller. So the VPC is simulating the controller in this setup. So we already did the configurations for this topology. We have ISIS configured, we have BGP configured, we have HOVPN implemented, we have OSPF configured, and we already have end-to-end communication from BTS01 to BTS02. I mean from BTS towards the VPC, from the VPC towards the BTS, we have bidirectional communication already working okay. So when I log into the routers, for example, from the SPE, if I display BGP VPN v4 all peer, you will see that we have BGP peering session towards the CSGs and also towards the NPEs. On the UPE, we also have BGP sessions, display BGP VPN v4 all peer. You'll see that we have BGP session towards the SG. So we've implemented two BGP sessions so that they are redundant. When one session goes down, the other one can still advertise the routes that will be required for us to communicate with the controllers. When you check the IP routing table, display IP routing table, VPN instance to GVPN, you will see that we have a default route. So the default route has been advertised from the ASG or the SPE. Remember, that is how HOVPN solution works. We only advertise a default route towards the UPE. You can check the other VPN instances. If you check for 3G, you will find that we also have a default route advertised from the SG. On UPE2, we expect the same. Display IP routing table, VPN instance to GVPN. So you'll see that we have a default route. Even when you check on 3G VPN, we also have a default route. So we've successfully implemented HOVPN on this topology. And when you check on the BTS, we've already configured the BTSs also. So if I display IP routing table, you can see that we have the direct routes configured for different VRFs. On BTS2, display IP routing table, you have the interfaces configured, display IP interface brief. You'll see that we have these interfaces configured for different technologies. We can try to ping the VPC IPs. So I can ping, I will use the source, which is 10.160.10.10, and I will ping, maybe I'll do 1,000 packets so that it will allow us to do the verifications. So with 1,000 packets, I'm trying to ping the VPC IP for 2G. So you can see that the ping is through. We have end-to-end communication from the UPE, from the BTS towards the controller, the VPC, or the RNC, the BSC, or the EPG for the 4G or LTE technology. So we will have end-to-end communication. So remember, when you do the implementation of a network, you always have to test. For example, in this setup, we have a ring setup. So we have SP1 connecting to UP1, connecting to UP2, connecting to SPE2. So the scenario that we had is, what happens when we lose one of the links? What happens when we lose the link between UP2 and SPE2? We expect that traffic from BTS2 should be able to use the redundant path. Should be able to go to UP2, UP1, SP1, and then towards the controllers. But that was not the case. And the reason is we have a loop happening between the SPEs. So this is the issue that we are trying to, that we did troubleshooting, and we were able to identify some solutions that we can now use to solve the issue. So on this router, I'll do it. Let me shut down the link from UP2. So I'll do interface, or let me just do it from the initial setup. So I'll do interface gig 0/0/0. I'll shut down the interface between UP2 and SPE2. So once I shut down the interface, I expect that traffic from BTS02 should be able to switch and use the redundant path that is available through UP1 and SP1. Let's check the ping. So you can see that we already dropping packets. We already lost communication between the BTS and the VPC. And you can perform some, if I display IP routing table on this router, 1.1.1.6, the loopback of this BTS, this UP2, you will see that it's pointing towards SPE2. But that should not be the case. It should be pointing towards UP1. So again, if you try to trace, if I trace 1.1.6, you will see that we are having a loop happening between the nodes. So we need to be able to fix this issue to ensure that we don't have any loop occurring in the network, and then we should be able to have redundant path working. Our network should be okay. We shouldn't be having packet drop the same way we are having the packet drops, and we have available backup link. So on UP2, display BGP VPN v4 all peer. You will see that we have the BGP sessions up, but when I try to ping 1.1.1.3, we are able to ping 1.1.1.4, we are able to ping. So we need to find the reason why we are having packet drops on this network despite having the redundant path. And remember, when we are doing the implementation of a ring setup, we normally set up the back-to-back connection between the SPEs on the access ISIS. So we have ISIS 10 configured between SP1 and SPE2 to close the access ring. So when you look at the solutions that we had, solution number one, we can stop closing the ring. So this one can be a temporary solution, but it's not recommended. So you can choose not to configure access ISIS 10 between SP1 and SPE2. So if you check the IP routing table, if I display IP routing table and I do 1.1.6 verbose, you will see that we are having two routes. One is coming from aggregation process, another one is coming from the access process. But we are selecting the one that is coming from the aggregation process because it has a lower cost. So this one has a cost of 10, this one has a cost of 20. So we select the one with the lower cost because remember the preference value is the same. So we've selected the one with the lower cost. And when we do this, we end up having a loop in the network. So one of the solutions is we can stop implementing back-to-back access ISIS connection between the SPEs. But again, this is not a solution I will recommend because you still need to have that ISIS in place. So I can go ahead and shut down this interface, the back-to-back ISIS between SP1 and SPE2. So I do system view and then I'll paste, display this. So if I display ISIS peer, you will see that we've lost the ISIS between SP1 and SPE2 in ISIS process 10. When you check on BTS02, it will take some time for the services to restore because remember, the network has to converge again. But finally, it will converge and we will restore the services when we disable that back-to-back ISIS between the SPEs. So this one is taking time, but it will restore the services. So on SPE2, if I display ISIS peer, you can see that the ISIS peer is up only in ISIS 100. Display BGP VPN v4 all peer. BGP, VPN, v4 all peer. You see that 1.1.6 is still down, so it will take some time. You can see that now we have the ping going through. The ping has been restored. Remember, we had packet drops up here. Now it's going through because we've shut down the back-to-back ISIS between SP1 and SPE2. So that is one of the solutions, but I really recommend that because the best practice is you should close the access ring between the SGs or between the SPEs. So once I'll shut down this link, and some of these issues, they occur when you trigger them. So even when I enable ISIS, the back-to-back ISIS between these two nodes, and do shutdown, display ISIS peer. So the ISIS is up. So when the ISIS is up, the ISIS access process between SPEs, now it's fully up. You will see that the ping is still going through because now the network, like the state of the network hasn't changed. But when you trigger it, which will happen whenever that link happens, there is a change in the network. The messages have been propagated across the network, then we end up having a communication issue in the network. So I will not recommend you disabling the ISIS between the two SPs or between the two ASGs. So let's look at solution 2. So solution 2 is you can increase cost on the back-to-back connection for ISIS 100 between the SPs. So also I don't recommend this solution. So what I need to do, let me go back to this router. On SP1, I will undo shutdown. So I'll display ISIS peer. So we expect that ISIS to restore. We'll give it some time. And once we have these ISIS adjacent restored, now we have everything back to normal. We have ISIS back-to-back ISIS between the SPs. We've enabled this link between UPE2 and SPE2. Let's check the ping test from the BTS side. So on the BTS02, the ping is still going through okay. Again, I will shut down that link again. So I'll do shutdown. Display ISIS peer. We've lost the ISIS between the SPs. How is the ping? You can see that we are having packet loss again. So on the SP1, if I do a trace again, 1.1.1.6, you see that we are again having loops because we've restored the ISIS between the two SPs. The link has gone down again and it has triggered the loop again to happen. So what we can do is we can increase. I remember on this router, when I did display IP routing table 1.1.1.6 verbose, we saw that we have the route that is coming in ISIS process 10 has a cost of 20. The one that is coming in ISIS process 100 has a cost of 10. So this one will be selected and it will cause loops in the network. So this solution, what it suggests is we can increase the cost on the ISIS 100 back-to-back connection between the SPE. And again, this is not recommended. And when you do this, you need to have very proper analysis on the cost planning of the entire network so that you can avoid suboptimal routing in the network. So what will happen when we increase the cost between, so we are having packet drops again. Let me see. We are still having packet drops, yes. So when I log into SP1, I do interface gigabit 0/0/1. I set ISIS cost to 1000 maybe or 100. We can just set it to 100 or 1000. I go back to SPE2. Remember, you need to do it on both legs, on both ends of the link. Interface 0/0/1. I do ISIS cost of 100. So we now have ISIS cost of 100 configured between SP1 and SP2 on the ISIS 100 link. When we check the ping, you can see that the ping has restored. So we fixed the issue temporarily, but not the best solution for fixing this issue. Why is it not the best solution? When you check on SP2, if you try to display IP routing table and then you check the route 1.1.1.1.3, which is the loopback IP of SP2, you will see that it's going through gigabit 002. So it's going through this way. So it will have from SP2, it will go to NPE2 to NP1, SP1. But we have the back-to-back connection in ISIS 100, but it has a higher cost. So when you do verbose, I also expect that we should be having two routes, one with a higher cost, another one with a lower cost. You can see that this one has a cost of 30. The other one has a cost of 1,100. And we are selecting the one with lower cost. So we are going through SPE, and from SPE we go to NPE, we go to NP1 and then SP1. When we check the route of the other SG on SP1, display IP routing table 1.1.1.4 verbose, you see that we have the same issue. We are also going through from SP1 to NP1 to NPE2 and then to SPE2. That is suboptimal. It's not optimal routing. So we need to avoid such kind of scenarios. And that's why I mentioned that for you to use this solution, you really need to do some proper cost analysis of the entire network so that you avoid such kind of suboptimal routing in the network. So again, I don't recommend this solution. So I will restore with a cost of so I will do undo ISIS cost on both ends. So it is interface gig 0/0/1, undo ISIS cost. So of course, again, the state has not changed in the network. Our ping is still going through without any problem. And the network, everything is okay until it will be triggered again. And there will be downtime in the network. So some issues may not happen when you are setting up the network, but once there are some changes in the protocols, then we may have a loop, we may have issues happening in the network, which you did not expect. So again, I have restored it. So I will go to SP2, quit, interface gig 0/0/0. I will undo shutdown. So display ISIS peer, we expect the peer to come up again between the UPE and SP02. We'll give it some time to converge. So we have now converged again. The ping is still going okay, no problem, just one packet loss during switchover. So what I need to do is I will go ahead and shut down the link again. So when I shut down this link, you see that again we are having packet drops in the network because we've triggered some change in the network. So there is packet loss that is experienced when you try to reach the core or the BTS, the controllers, the BSC, the RNC from the BTS. So we are not able to again switch the traffic to the redundant path through UP1, SP1, either NP1 to the controllers. So we have a similar issue occurring again. So I've said this is not recommended. We've restored it. The third option, the one that you can use, is the route tagging. So with route tagging is when you are importing routes between these processes. Access process, when we import this route from access to aggregation, you give it a tag. When we import the routes from aggregation to access, you also give it a tag. And what we are trying to control is once you've imported these routes to access, these routes should not be imported again back to the aggregation. And once you've imported these routes from aggregation to access, these routes should not be imported again back to the aggregation. So there should be only one way import, not both ways. Like we import from access to aggregation, once that route is in aggregation, it's also imported back to the access. From aggregation to access, access to aggregation. No, we don't want that one to happen. So we can use tagging. So route tagging can be used in such a scenario to solve the loop issue. So you can see that we have two policies. Policy 1, access to aggregation. And for this policy, we have a prefix. Of course, when you are doing policies, it's always good to have prefixes. So we have prefix we are calling access to aggregation. So for access to aggregation, we are importing the loopback IP and the back-to-back connection between the routers. And once we have that route policy, we are marking these routes, or we are tagging this route with tag 1. We go next to the route policy access to aggregation. Again, we have deny node 10, node 20, and you can see that if merge tag 100. So we are applying the routes. Like when you find a route and this route has a tag of 100, you don't import it to access because that route came from aggregation. So you don't have to import it back to the aggregation again. It came from the aggregation with a tag of 100. It should not be imported back to aggregation again. And you can see that we have another policy, route policy, aggregation to access. So aggregation to access, remember we'll have an import from aggregation to access. And when we do that, we don't want to again do the back-to-back import of routes from access to aggregation, again aggregation to access. We are importing the same prefixes. No. So we need to tag these routes correctly so that we can control that re-importing of the access routes back to aggregation. Like we import a route from access to aggregation. Once this route is in aggregation, we should not import it back to access. The same way, when we import routes from access to aggregation, or we import routes from aggregation to access, once this route is in the access process, we should not import it back to the aggregation. So this one can be achieved when we are using the route tagging. So you see that we've configured two policies, one access to aggregation, and this one, when we are doing that, we are applying a tag of 1. And when we are importing access to aggregation, we are denying the routes that comes with a tag of 100. We have aggregation to access, we deny the routes that are coming with a tag of 1. We allow the ones that are, when we are importing now, when we are importing access to aggregation, this is aggregation to access, we are applying a tag of 100. And this tag of 100 will be denied up here. And this tag 1 is also denied down here. So we are avoiding that back and forth route import between access and aggregation to ensure that we don't have loops occurring in the network. So you can see that we have the prefixes. These prefixes have been defined. And again, within the IS-IS process 10, you import route IS-IS 100. It's always good practice that you set a higher cost on that route, or 10,000, 1,000, 100, depending on how your network is. When you also import IS-IS 10 to aggregation, you also tag the routes using the route policy, and again, you configure the cost. So these are the commands that we need to run on SP1. Let's first check that. So you can see that the ping is still not going through. So on SP1, I'll configure the policies, and again we need to configure these prefixes. So one thing I can do, I can just copy everything. We will just verify that everything is okay, especially when we do the route import. So display current configuration, configuration IS-IS. You see that we have So in ISIS 10, I will undo this policy, import route direct, just so that we have one policy. So I'll display current configuration, configuration ISIS. You see that now we are using a route policy, and this route policy, it's access to aggregation, aggregation to access. Let's see whether our ping is going through. So it will take some time, but again, we need to apply the same on both SP1 and SP2. So I will copy this, go to SP2, I'll paste, display current configuration, configuration ISIS. So with this, I'll also ISIS 10 undo import route direct. We don't need it anymore. Let's check on the BTS2. You see that our ping has restored. So there are packet drops once we've done proper route import between the access and aggregation. Now you can see that the services have been restored with these policies. So when you are doing route policies, you really need to follow the best practices. You really need to understand what those prefixes or what those policies are doing in the network. Even if it's a new network that you are managing, you really need to analyze the policies to understand what they are doing and the objectives, or else you may find yourself in trouble trying to fix issues that you really did not expect to happen in the network. So with this route tagging, we are able to control the route import between the access and aggregation. So if I display, maybe, I don't know whether it will display IP route, display IP routing table, protocol ISIS. Then I will do 1.1. Let me see whether I can do a prefix, IP routing table, 1.1.1.5 verbose. So you can see that this one has a tag of 1. If you display .6 verbose, you can see that this one also has a tag of 1. When we display the routes on the display IP routing table, 1.1.1.3 verbose, you see that it has a tag of 100. So it's being tagged with a tag of 100. The other access routes to the aggregation, they are being tagged with a tag of 1, and then you don't do the back to back import, back and forth import of routes between access and aggregation, and then back to access. So that one will cause loops, which we are trying to avoid in the network. So you can see that this one, it has fixed the issue. We are able to have communication from BTS2 to the controller side, and no packet drops are experienced so far. So again, that one can solve the issue. So this one is a good one that you can use, you can implement in the network, so that you are not importing routes from access to aggregation and then back to access, or either aggregation to access and then back to aggregation. So this is what we are trying to avoid when we are tagging the routes and denying those that we've imported from access back to access, or those that we've imported from aggregation again back to aggregation. So we look at the next solution. The next solution is inheriting the IGP cost. So remember when so let me disable this policy, or we can leave it in place. When we did the route import, or the route import between access and aggregation without proper policies, one of the issue is when you checked the route on SP1, it was having a lower cost. It was having a cost of 10. But you expect that route to be having a cost of, like, it should be having the correct cost from UP1, from UP2 to UP1 to SP1. Remember, the default cost of ISIS is 10. So this one should be having a cost of 10, a cost of 10, which means that route when it's on SP1, it should be having a cost of 20. But you are seeing some weird cost value that you don't expect to find when you are doing the ISIS as your IGP. So one of the things that you can do is to inherit cost. So that is also a solution that you can use. So on this SP1, if I do ISIS 10, display this, we have import route ISIS 10. ISIS 100 cost is set to 10,000. Let me check whether the ping is still going through. So the ping is still going through. So we'll do just slight adjustment on this SP01, and so we'll do import route ISIS 100, and then you use inherit cost, and then you can use the policy. So you can use policy aggregation to access. We can still even use our initial import access. This is import aggregation loopbacks. Quit ISIS 100. Display this. I'll do import route ISIS 10, inherit cost, and then route policy, import access to aggregation. On SPE2, we need to do the same. So this one will be display this. I'll do import route ISIS 100, inherit cost. So we are inheriting the initial cost that this route was coming with. So if it was coming with a cost of 100, we are inheriting that cost of 100. We are not dropping the cost values that these routes were coming with. So inherit cost, and then you do route policy, import. This is aggregation to access. I do ISIS 100, display this, can import route ISIS 10, inherit cost, route policy, import. This is access to aggregation. So we don't expect to have packet drops. We should still be able to communicate towards the controllers without any problems. So even if we shut down, let me try to trigger it and see. So interface gig 0/0/0, this is the interface towards UPE2. I'll do undo shutdown. The switchover may have maybe one packet drop, sometimes no packet drops if it's quick enough. And then on SPE2, let me trigger it again and see. So I do shut down. You see that we don't have packet drops. The ping is still going through okay, because we are inheriting the cost values. And now the routers will be able to select the optimal path without having any. So if I display IP routing table 1.1.1.6 verbose, you see that this one now has a cost of 20 on this router. On SPE2, if I display IP routing table 1.1.1.6, again verbose, you see that we have one with a cost of 120, another one with a cost of 30, and we are selecting the one with cost of 30. But again, you can see, so of course I've changed the policy, so you may not be able to see the tags because I've used a different policy. But again, once you use this solution, you are able to fix the issue. So you inherit the cost that the route was coming in with when you are doing the route import. So this is also a solution that you can consider. And the good thing is some of these solutions can be combined. You need to do proper cost planning. That is mandatory. you need to use route policies when you are importing routes. And again, you can use the route tagging together with inherit cost, and then you should be able to have a very robust network that doesn't have any loops. So another solution that you can use is to set costs. So you can see that you can manually set cost when you are doing route import. For example, when you are importing in ISIS 100, when you do import ISIS 10, you do what? You add the cost manually. And this cost value, of course, you must consider the network topology. So this is also a solution that you can use. So these are the solutions that we discussed in our previous troubleshooting session. You can see that session 1, you stop closing the ISIS access ring on the SPs. This is not recommended. Solution 2, you increase cost on back-to-back connection between the SPEs in ISIS 100. This is not recommended because it may lead to suboptimal routing in the network. It will lead to some issues unless you've done some proper planning of the cost. Then you can use this method. The best solution that you can use, you can do route tagging. So you tag routes when you are doing import from access to aggregation and from aggregation to access. And then you ensure that you have the deny. So you have the deny that is ensuring that we don't have the back to forth route import between access and aggregation and then back to access. So the issue is when you import route, you are importing route from access. You take it to aggregation. If you don't have a route policy in place that will control the back-to-back import of this route policy, of these prefixes, we'll have these prefixes imported back to access. So this is what we are preventing in this kind of setup. Again, when you do access, you have aggregation, you're importing it to access. If you don't have anything, any policy or any tagging in place to control this, what we'll have is we'll have these routes imported back to aggregation. And then we have a serious loop occurring in the network. So with route tagging, we are able to control this and ensure that we don't have that back to forth route import between the access and aggregation processes. Again, you can also use the inheriting of cost. So you inherit the initial cost that these routes were coming with when you are doing route import from access to aggregation or from aggregation to access. So you inherit the initial costs. Again, you can manually set the costs for imported routes. When you do route import, you specify a higher cost. So many times we'll configure this cost to be higher values so that when it's reimported into aggregation, it will not be considered. It has a very high cost, so it will never be considered as an option when traffic is forwarded from the one node to another. So these are the solutions that we discussed. This is just a summary of that session. If you missed the HOVPN implementation lab session, you can go through it. If you missed the troubleshooting session, you can go through it. It was very interactive, it was very engaging, and there was a lot to discuss, a lot to share, and there is a lot that you can learn from those sessions. We have had multiple sessions that we've covered in the live training sessions, and we have other recorded sessions on our channel. So again, I thank you all for those who are able to join the troubleshooting session, and I'm grateful for that. And I hope that soon we will be having another IPRAN session, and I hope to see you all joining that session. Thank you so much, guys. And again, just a kind request that if you've watched this session and you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned in for more upcoming sessions. Also, remember to like, comment, and share this session with your connections. Thank you so much, and see you in the next episode.